we're trying to develop manipulator structures for surgeons that assist them in these minimally invasive surgeries and improve the outcome of these procedures. The system that we're demonstrating today is our single port overtube system that was funded by the German Research Foundation and was developed here at our Institute for Microtechnology and Medical Device Technology in cooperation with our clinical partners, the University Hospital Rechts der Isar here in Munich and the University Hospital in Würzburg. The main thing about minimally invasive surgery is that it is great for the patient because it reduces the hospital stay, it reduces the patient trauma in general, but it is very demanding for the surgeon himself. And so in order to make it easier for the surgeon, we develop these additively manufactured systems to help the surgeon have more dexterity when operating inside the body. Every patient is different and every procedure is different, so that means that the requirements for our system change every time. Since this is all 3D printed, it can all be individualized for each use case. And since we're trying to automate the entire design process, we need to anticipate all these different requirements that could arise from different use cases. We can individualize our product, basically. So we can take a look at the procedure that we're trying to perform, at the anatomy of the patient that we're working with, and then adapt our whole system to match these requirements. One of the major challenges that we have with this system is actually designing it automatically in a way that it is reliable. We've gotten good feedback from the surgeons who tested the system, but now we really need a large-scale trial to actually prove that this individualized approach that we're taking has significant advantages.